I might have said the first half we were going to review factoring, but definitely not 2 weeks for sure. All right, we're just going to take a few little brief notes right here on the side of this paper, and then we're going to practice. Actually, in line with his question, I am looking at having a test on Thursday. So we're going to finish this chapter today for the most part. We'll have a little bit maybe to do on Tuesday, and then I'm looking at having a test on Thursday of next week. It's a short test, so you'll have half the class to finish the test. So we'll see on that. But there are 3 rules that you need for radicals, and let me tell you what they are. All right, number 1. Well, I'm just going to call this rules for radicals. And honestly, we're not going to do a lot of work on this paper, so don't worry about, like, I'm going to need work for my problems because I actually made another worksheet. So number 1 is you can't take the even root of a negative. You can't take the even root of a negative. Now, jot that down, and I'll explain why that's the case. Okay, so you can't take the even root, in other words, the second root or the fourth root or the sixth root. And here's why. If you look at our power paper, let's just look at the squares. Well, we can look at the squares and the fourths. There is no number in the universe that you can square and get a negative. So even if this was a negative 9, for example, negative 9 times negative 9 is going to be positive 81. You can never square or raise it to the second, fourth, sixth, even power, and get out a negative. That goes back to your pre-algebra rules for signs. So therefore, you can't take the square root of a negative. Now let me just give you an example. Let's say the square root of negative 4. The square root of negative 4. The reason that we know the square root of 4 is 2. We know that. But you can't take the square root of negative 4 because positive 2 and positive 2 would give you a positive 4. And negative 2 and negative 2 would give you a positive 4. So there's no way to get a negative by squaring a number. It's not possible. Now, this is one of our next sections, so we'll study this in the section coming up. But does anybody know what you can do there? What can you do if you have a negative under a radical? What kind of numbers are those? Does anybody know? Imaginary. This is an imaginary number. It is a fake imaginary number. It is not on the real number system that you've probably studied your whole entire life. This does exist, but it's an imaginary number, and that's another section of this class on another day. But a lot of these notes that we're taking right today, we'll just flip back to page E when we start on our imaginary numbers. But for today, I'm just going to write down the word imaginary. This is an imaginary number. And again, we got a whole lesson on that, so... All right, that's rule number 1, is you can't take the even root of a negative. I said I was going to give you 3 rules, but I think I might can do it in 2. Let's see. All right, let's do it in 2 rules instead of 3. So rule number 2. Rule number 2. For exponents. Now, this rule that I'm giving you, just like we learned on the first or second day of class, the rules for exponents with monomials. And Kayla, tell us where exponents are located. Right, top right. So this rule that I'm getting ready to write down on this piece of paper only applies to exponents. But that's not scary because we've already had some rules that only apply to exponents. But here's the rule. For exponents, you divide the power by the root. And then you got to write this down too. The whole number gets out. and the remainder gets stuck. Now, that's all of our notes for today. Let me zoom in on that. Everything else we're going to do right now is going to be just practice. Okay? So we're going to practice for a little while, then we'll probably take our break, and then when we come back, we'll finish up radicals. There's one more radical topic, but we'll just practice a little bit right now. Now make sure you have your factor sheet or your power sheet out, because we're going to use that to determine our powers. Now I'm going to have to turn my paper because I want to actually do some things on the left. So those are our rules. Number one, you can't take the even root of a negative. I'm pretty sure that's not going to come up today. But it will come up in a couple days when we study imaginary numbers. And you'll learn that square root of -4 is 2i. And the I stands for the imaginary part. But again, that's not going to affect you today. I'm just going ahead and telling you. The other rule is very, very important. It is for exponents. And for exponents, oh, I knew I was forgetting something. You do the power over the root. Now, Robert already commented on my teaching style. I do like to use a lot of tricks and stories and things like that. So here goes one of them. How can you keep straight that the rule is the power on top and the root on the bottom? In other words, somehow you have to always remind yourself that it's P over R and not R over P, because this is something that students struggled with in the past. Can anybody think of a mnemonic device that could help you remember that it's P on top and R on the bottom? Wait, sorry, start over. What did you say?
The plant's up top and the root's up underneath it.
Oh, that's good. That's good. I'm not even going to tell you mine. He said that the plant's up top and the roots are in the bottom. Did somebody tell you that, or you just came up with that?
What you have? The P before the R? That's
No, L-M-N-O-P-Q-R. That's true. P comes before R in the alphabet. That's good. That's good. Well, mine was, let me go ahead and tell you, mine was it's a little toy figurine that predominantly boys play with. Power Rangers. Power Rangers. So I use that one because the first word is power. So it's the power over the root. And how can you remember that? Power Rangers. You can also think about it like Justice said, the plant is at the top and the roots are at the bottom. Or you can go with Mario, P comes before R in the alphabet. But if you get that reversed, you're in trouble. And this rule right here we use from now to December. So it's always P on top and it's always R on the bottom, and that's never going to change. All right, let's turn our paper to the side and just practice a few. I'm going to start with some easy ones, which would be number 2. I want to teach you how to use this chart right here. Matthew, what could you possibly be doing on that laptop? Yeah, you should. Okay, I'm going to try to show you how to use this sheet right here. This is asking for the 4th root of 81. Okay, you might know that off the top of your head, but if you don't, you're going to pull your sheet out and you're going to say, all right, it's asking for the 4th root, so I'm going to go to the 4th column. And if you see 81 on there, then you can take the 4th root of 81. So all you do is you find the 4th column, the number that you want is 81, and you go all the way to the left, and the answer is 3. So the 4th root of 81 is 3. Okay, that's the answer. That's all you're doing right there. 4th root of 81 is 3. We're only going to do a couple on this worksheet. I actually made a worksheet right hot off the press before I came to class today. So we're only going to do a few on here. Same thing for number 3. Let's look at number 3. Now, this one's easy because 1, the 5th root of 1, 6th root of 1, 10th root of 1, millionth root of 1, 10 zillionth root of 1 is still 1. But the point is, do you know how to use the chart? So since this is 5th root, you're going to go to your chart and you're going to look on the 5th column. You're going to find the number, which is 1, and then you go all the way over to the left, and the answer, well, my paper, go all the way over here, and the answer is 1. So the 5th root of 1 is 1. All right, those are the easiest two on the worksheet. I want to jump to number, well, let's do 6. Let's do 6. This is a good one. Paper. Hold on, let me get my paper straightened out. All right, number 6. Now, this one's different. We're talking about the square root. So I'm going to try to use my paper, and I go to the square column, which is here, and I look for 24. 1, 4, 9, 16, 25. 24 is not on there. That tells me that 24 is not a perfect square. Now, that doesn't mean you can't simplify it, but you cannot take the square root of 64 with a nice, neat integer. So what I do instead is, here's where 24 comes just before here, so I just back it up. Will 16 go into 24? No. Will 9 go into 24? No. I'm trying to find the perfect square that will go into 24. Will 4 go into 24? Yes, it will. So what you're going to do on a problem like this is you're going to break it down to the two roots, one of which needs to be a perfect square. So 6 is not a perfect square, but 4 is. And you always want to do the largest one you can possibly find. Otherwise, you're going to have to break it down twice. And I'll show you that on the board. I'm not going to, well, I guess I got room to show you there. All right, I'm going to deal with the x later. So let's just get our answer here. What is the square root of 4? 2. It's a plain 2, not radical 2, not square root of 2, not half, nothing but a 2. And you can't take the square root of 6. Now skip a little bit of space because we're going to have an x that comes out. And 6 gets stuck in the radical. I cannot do anything with that 6. Even if I tried, it would break down to the square root of 2 and the square root of 3. Well, I can't take the square root of 2 and I can't take the square root of 3, so that lets me know I'm done. But now we're going to use our power over root rule. We're plants on the top, roots are on the bottom. I love that. So let me show you how this works, okay? I'm going to show it to you real slow this time because it is a little trick, and we'll have to catch up with it. All right, so the power of this x is 2. So the power is 2. And even if you can't see it, what is the root? What's the little root stuck there, even if you can't see it? What kind of sign is this? By definition, what does this mean? 2. It's the square root sign. So by definition, the root is 2. So what we're going to do, I'm going to slide my paper down a little bit so I can write this. Again, don't worry about, like if you go up here, that's fine. We're not doing very many on this paper at all. We're going to divide the power, which is 2, by the root, which in this case is also 2. Now, what's 2 divided by 2? 1. We have 1 remainder 0.
So is the root always going to be 2?
No. Like if you look at number 8, what's the root on number 8?
4.
Yep. What's the root on number 10?
3.
What's the root on number 12?
3.
What's the root on number 3?
5.
What's the root on number 2?
4.
Right. But if it doesn't show a number, it is 2. So if it doesn't show a number, it's assumed to be 2 because it's the square root symbol. If it's not 2, it's going to have to show it to you. Now, I'm going to flip my paper just really quick. Let's go back to what we wrote a few minutes ago. For the exponents, and that's what I'm talking about. I'm talking about the exponent on that x. You're going to divide the power by the root. The whole number gets out. In other words, it gets out of the remainder. However many whole numbers there are, that's how many x's get out. But the remainder gets stuck. So go back to what I've written. I said that 2 divided by 2 was 1 remainder 0. So the whole number is going to get out. I'm going to write the word out. Oh gosh, this keeps focusing. Let's see if I can get it to lock. All right. And then the remainder, which in this case is 0, gets stuck. Now, what do I mean? This x is going to get out of the radical. So put it over there with the 2. It's going to be out here like this. And do any x's get stuck with the 6? No. So that's the answer. 2x radical 6. That's the final answer. Now, let's take a breather and look at that. Because that is the basics of simplifying radicals. Now, if you look over that worksheet, it really quickly gets way harder. But that's the basic, okay? I do want to show you something, though, right here while we're on this paper. And you don't need to write this down. Don't write this down. I'm going to just put a sticky note over my work. Let me go back and show you what a lot of people are going to do for 24. A lot of people are going to say, all right, square root of 24. Well, that is the square root of 8 times the square root of 3. And that's true. 8 times 3 is 24. So the square root of 24 is the square root of 8 times the square root of 3. That's true, right? But can you take the square root of 8? No. And can you take the square root of 3? No. So you're going to have to go one more step. And the reason that you're going to have to go another step is because you didn't use anything from the squared column to begin with. 8's not on there, and 3's not on there. Now, you can still get it right. Let me show you what you got to do. You would have to keep going and break this down to the square root of 4 and the square root of 2. This, you just keep that as square root of 3. Now, you go one more step, and we can simplify it. Because what is the square root of 4? 2. So this would become a 2. And these two would be stuck, and the square root of 2 times the square root of 3 is the square root of 6. And that's what we got. We got 2 square root of 6. But you see how this person's going to have to do an extra step right here because they didn't break it down to a perfect square to begin with. That's fine. Always check. If it can be broken down some more, keep going. But this is an extra step. And the reason they had to do the extra step is because they didn't find the perfect square to begin with. All right, let's try to find one more easy one. Easy one. I don't see any easy ones on here. All right, let's change to number 7. Let's go to 7. 7's a little bit different. You treat radicals a lot like you treat monomials and polynomials, okay? I always kind of, in the past, and I've tried to gear away from this, but honestly, it's a really good analogy. This is like a jail. This radical is kind of like a jail. So these people are free. 3 and 4 are free. So they can mingle. 3 times 4 is the same thing 3 times 4 has been your whole life. They're outside of the radical. So for number 7, 3 times 4 is 12. And then these people are both in the radical. But they can mingle. So 2 times 10 is radical 20. This is a good example because we're going to have to simplify that. So again, you treat radicals a lot like you do monomials or polynomials. A lot of the same rules apply. You can't add or subtract unless they're like terms. All right, am I done with that? Should I put a box around that or could I simplify that some more? Robert's thinking he can simplify it some more. I agree. So if you go to your perfect squares, we're thinking about this 20 right here. This 20 is what we want to break down. What number right in this area, because these are your perfect squares, will go into 20? 4. So we got to break it down again. This is going to break down to the square root of 4 times the square root of 5. Go over here because I'm kind of running out of room. All right, the whole point is that you found a perfect square. So what is the square root of 4? 2. So this 2 is going to come out here. It's going to be multiplied by what was already out. And then the 5 is going to get stuck. So it's going to be 24 square root of 5. That's the final answer for that problem. 12 times 2. 12 times 2 is 24. The 2 came out right there. This 2 jumps out, and 2 times 12 is 24. I scratched out the 2, but this was the square root of 4, and the square root of 4 is 2, and it jumps out. All right, while we're here, y'all try 9. Let's stay right there. 9 is almost identical to 7, so y'all try 9 really quick. Radicals is one of those topics, it's like monomials or anything else. I could do a million examples with you, and Tuesday you could come back, well, what about this? Like, we cannot possibly do every example that you could ever find with radicals. It's not something that we use a lot in this class. We use it a little bit later on. In a couple of weeks, we'll do the quadratic formula, and we use radicals there. But if everybody in here is going to have to take trig, that's the next class, and you use radicals a lot on trig. If you know anything about the unit circle, most of the numbers in the unit circle involve a radical. So radicals, it doesn't feel super important this semester. You're going to think, why did you waste our time that day teaching us radicals? But then when you hit 172 the first day of January, you'll be glad that you learned about radicals, because it's something that's used throughout that time. All right, while y'all are working, I'm going to work on it.
Something like that in the real world, why couldn't you just plug that in your calculator instead of simplifying it and just get the answer?
It would give you a decimal. It would depend on what you were doing. So if you were, for example, substation, I don't know a lot about substation, but let's talk about construction. I know a little bit about that. This is an exact answer. 16 radical 3 is an exact answer. If you were to put that in your calculator, like Nathan said, just type it and press enter. Let's see what 16 square root of 3 is. 16 square root of 3 is an irrational number. It's a non-repeating decimal, 27.712.812, blah, 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 blah. But that's not exactly the same, because you would have to round this right here. You'd have to round that. So if you wanted an exact answer, you would have to have 16 radical 3. If they asked for a decimal, it would be 27.71. But it just depends on what you're doing. But for this class, it's an exact answer. We don't use decimals a whole lot in here. All right, y'all got what I got on number 9, 16 radical 3? Okay. Let's do number 10. Mario asked about the, this is what's called the index of the number. So right here, this is the cube root, because the 3 is in the index. If there's no number there, it is assumed to be square root. So cube root of 27, again, this is just practicing your chart. So go to cubes, and you see 27, and then you go all the way over to the left to get the answer. So the cube root of 27 is 3. So it's just going to be a plain 3 on the top. And then you'll do the same thing for 216. So find cube roots. Here we are. There's cubes. There's 216. And you go all the way over, and it is 6. You probably didn't know that. I don't walk around with a lot of cube roots in my head. And I don't have hardly any 4th roots or 5th roots. I use this paper a lot. You're going to be able to use, just in case you want to know, this piece of paper on your first test. You'll be able to write anything you want to on that piece of paper right there. So don't lose it. Okay? Probably your first and second test, but definitely your first test. So the cube root of 216 is 6, and 3 6 reduces to 1/2. So the answer there is 1/2.
What do we do at 27? Oh, okay.
I took the cube root of it.
I got you.
I'm sorry. All right. Let's do 11 together. 11. All right. Again, you treat these a lot like you do monomials. These people, 15 and 3, are outside and they can fellowship. What has 15 divided by 3 been your whole entire life? 5. And where would the 5 be? Top or bottom? Top. Okay, that's going to change over here on number 12. So we're going to have a 5 on the top. And then your little 8 and your 2, they can also fellowship because they're both in the radical. So radical 8 divided by radical 2. What's the square root of 8 divided by the square root of 2? Square root of 4. Still a square root. And then we're like, oh, well, I can take the square root of 4. The square root of 4 is just 2. So it's 5 times 2, and your answer is 10. All right, try 12. 12 is almost exactly like that. The only difference is you've got cube roots instead of square roots. So let's try 12. It's exactly like 11. The only difference is you're doing cube root instead of square root. You just look at a different column on your paper. That's what I'm saying. Just a different column on your paper. Go ahead and do this. These are grouped together. 3 over 9 is 1/3. Cube root of that divided by the cube root of that is the cube root of 27. The cube root of 27 is 3. And 3 divided by 3 is 1. All right, those of you that did that one, do you agree with me on that one? All right, Dante says yes. I just read them all on. Okay, so how did I get that? I divided the cube root of 54 divided by the cube root of 2. No, not on that sheet. I just did 54 divided by 2, and that's where I got my 27. So 54 divided by 2 is 27, and the 27 is under the cube root because 54 was under the cube root and 2 was under the cube root. So I just combined these two. 54 divided by 2 is 27. That right there gives you that 27. That's where that came from. And then the cube root of 27 is 3, based on my paper. And I already had a 3 on the bottom. Now watch how I reduce that. 3 over 9 is 1 on top and 3 on the bottom because 9 is bigger than 3. So it's 1/3. And then you take the cube root of 27, which is 3. And 3 divided by 3 is 1. All right, let me zoom out on what we've done so far just so we can kind of get a big picture of what we've practiced because we've only done a few. We only got one more type. All right, so far we practiced number 6. This is just a straight simplification. All you did here was simplify. We practiced number 3. That's also, I'm sorry, we did these up here. 2 and 3, those are simplified. So 2, 3, and 6, we simplified. There was no operation to be performed. 7 and 9, what would you say we did there? What operation was in 7 and 9? Multiplication. So we've done simplify, we've done multiply, and then these last two we divided. So what operations have we not covered? Add and subtract. So let's do one of those. Let's go to turn your paper the opposite direction. Let's go to number 5. Let's go to number 5 and do an addition and subtraction. And we're just going to do this one problem. All right, we're going to take this in little baby parts. Okay, this is what I'm gonna assign you. I'm going to assign each of you a part to do. So pay real close attention. All right, Tom, Nathan, Mario, and Justice. Y'all need to do that right there. All you need to do is simplify that part. That's y'all's part. Y'all simplify that. All right, then we have Robert, Ethan, and Caleb. Y'all simplify that plus 24. All right, then we have Dante, Colin, and Kayla. Dante, Colin, Kayla, is it with a C or K? K. Y'all simplify the square root of 180. And that leaves Matthew, Cam, and Daniel right here. So I just want you to simplify your one part, Matthew, Cam, and Daniel. Let's see if we can simplify that part, and then we'll put it together and we'll add and subtract them. So you're looking, this is square roots, so you're going to be looking for a number on the squared column that fits whatever your group has. Try to find the biggest square root that's on your column. 180 is pretty big. And you can play around with your calculator too to try to find that number. That's fine. But Nathan asked about, you're not going to be able to just put it in your calculator and give a decimal answer because it's going to say give it as an exact answer, not an estimate.
You want us to simplify all the way down?
Which one are you?
To
Square root of 24 needs to be as simplified as it can possibly get. Yes, as simplified as square root of 24 can ever be. And it's okay if you have to keep going. Sometimes you don't hit it the first time and you realize there's another 4 that you can take out, or there's another 16 you can take out, or oh gosh, I should have done 9 to begin with. That's okay. You don't always get it the first time. You just have to make sure that yours is complete at the end. But it could take a couple of steps. Yeah, we got one more topic. We're going to take a break. We've got one more topic after we take our break, and then it's on radicals. And then, yeah, we're going to review on Tuesday, finish this up, and then we're going to have a little test on Thursday at the beginning of class.
Is there going to be a study guide?
There'll be a review guide. That's what I'm looking for right now. Yeah, there's the review guide right there, but I think it's already in your packet. It should be at the back of the packet. Covers everything on the test. Should be the last, few pages. All right, T, N, M, and J. Mario, what did you get for your simplification?
I got the square root of 4 and 5.
Yeah.
And then I take the square root of
Uh-huh.
2.
2. Uh-huh.
2 times 5.
Good.
10.
Uh-huh. So 10 square root of 5. Good. All right, REC. Robert, what'd you break 24 down to?
Square root of 1, square root of 6,
Uh-huh.
and square root of 4 is 2.
Okay. Good. Can't do anything about that. All right, Kayla, what did you break 180 down to? Now, you might not have found the best thing the first time. You might have had to keep going, but what did you start with? 36 and 5. You want to start with the biggest square root possible. So she found out that this is the square root of 36 times the square root of 5. The square root of 36 is 6, so she's got 6 radical 5. And then the last one, Matthew, what did you break 54 down to?
21 square root of 6.
Yeah, but what did you break it down to get that?
30.
What did you break 54 down to?
3.7. We broke it down into square root of 9 and square root of 6.
Okay, square root of 9 and square root of 6. The square root of 9 is a 3, so that comes out here. You already had a 7, so now you've got 21 square root of 6. Oh, where am I supposed to put my answer here? Oh, 21 square root of 6. There we go, right there. All right, now let's look at what we've got. So we had 4 different groups that came up with 4 different terms. What do you think we're going to be able to do with that 10 radical 5 and that negative 6 radical 5? Are they like terms? Yes, we're going to be able to put them together. Now, wait a minute. This is not our first rodeo. We've been together, what? Has it been 2 weeks today? All right, we've been together 2 weeks. We've been together a while. So remember, you don't have to write this down. Remember the very first thing we learned about PEMDAS is what do you do? What comes after addition and subtraction in PEMDAS? Nothing. Remember that? So the same rules that we use for polynomials, we're getting ready to apply to this radical. So what I'm saying is, when you add a 10 radical 5 and a 6 radical 5, you do nothing to the radical. It's still a radical 5. So 10 radical 5s minus 6 radical 5s is how many radical 5s? 4. So that stays 4 and radical 5. And then we're going to be able to do the same thing over here. Plus 2 radical 6 and negative 21 radical 6. Those are like terms. And when you add and subtract like terms, you do nothing to the, in our first case, it was nothing to the exponents. Today, you do nothing to the radical. So 2 radical 6 minus 21 radical 6 is negative 19 radical 6. Now, again, I'm going to post this video on Moodle. And so you can go back and watch it as many times as you want to.
Where would you get the negative from?
The negative 21. That's what I'm talking about up top.
Yeah, how would it should be positive.
21.
Should it?
I'm not sure.
700. Yeah, you're right. I'm sorry. That's a plus 21. Sorry. You're right.
Crazy.
So 10. That's 31 now. 31. Is that right? 31.
You're adding
Because that's a positive, so that should have been a positive. 21. Oh, it's 23. Sorry. Oh my goodness, I'm gonna have to get white out on that one. I really messed that one up. Robert, I'm putting you on guard, Robert. You're the third oldest one in the room. Robert, when I mess up, stop me. Because look at what a mess I've got now on my paper. My paper's looking like a hot mess. All right. So I'm sorry. 2 plus 21 is 23 radical 6. There we go. Y'all agree with that? All right. Okay, we have corrected this. I apologize. This is a plus 23. That's my fault. When we took our quiz. Because a plus 2 radical 6 and a plus 21 radical 6 is a plus 23 radical 6.